Good afternoon to all of you. So first, I will discuss about the alpha beta pruning problems. Those were given in the last class. Many of you have already solved this, but maybe some of you have done the problem in a correct way or maybe in partially correct way. So I would like to explain the steps for the clarity. Okay. So see, if this is the tree. This is our game tree. In the first level, max player is playing. In the second level, min player is playing. And again, in the next level, max is playing. Here, min will play, but this is the end level. So, if from these two, max has to choose, then between 7 and 6, 7 will be chosen. So, from the beginning, alpha will be initialized to minus infinity and beta will be initialized to plus infinity. In this way, in this level also minus infinity and plus infinity. In this level also minus infinity and plus infinity. Minus infinity is for the value of alpha and beta's value is plus infinity. Now as in this level max player is playing, so between these two values 7 will be selected. Because 7 is bigger, max always wants to maximize his gain. So 7 will be selected and alpha's value will be 7. We know that whenever the value of alpha will be better than the current value of alpha, then value of alpha will be updated. As here 7 is better than minus infinity, that's why alpha value is updated to 7. Now here we know that value 7 will come. If 7 comes here, then what happens to this level? In this level, min player is playing. So as these two values are now still not available, so depending on this 7, min player will update its beta value. We know that whenever the current value of beta will be bigger than the new value of beta, that is the new value will be less than the current value of beta, then beta will be updated. So here beta's current value is plus infinity and the new value that is coming to beta is 7. So here beta's value will be updated to 7. Now at this level, when we are coming to this level, then alpha value is minus infinity and beta value is 7. Now again at this level, max player is playing. So between these two values, 8 and 5, 8 will be selected. So if 8 is selected, then what happens? This alpha value will be changed and will be changed to 8. So whenever we know that whenever alpha is greater than equal to beta, then pruning occurs. As here alpha is 8 and beta is 7, so alpha is bigger than beta, so we prune this. One pruning will occur here. So here what will happen? 8 or more value will come. If here any other subtree is present, from that subtree also maybe some bigger value may come. So here it is possible to have 8 or more value. But whatever be the value, as this node is having 7, so min player will always select this 7. That's why no need to check this, as we have got 8 here and 7 here, and it depends on min player to select these two select any value among these two. So min player will always select 7, not 8 or more. That's why this subtree is pruned. Now we come here. Here when we are coming to this state, then value of alpha is minus infinity and value of beta is 7 because we are following this. Now among these two values 2 and 3, what will happen? As max player is playing, max player will select the maximum value and that is 3. So alpha value will be updated and alpha value will be 3. Here no pruning is done. So in this node 3 will be selected. So for these nodes, these three nodes, this node will have value 7, this node will have value 8 or more, and this node will have value 3. So among these three, whenever mean player will select any one, then here 3 will come. So as 3 is coming to this level, now in this level alpha will be modified. As in this level max is playing, so alpha value will be modified and that will become 3. Now we go to this level with alpha value 3 and beta value plus infinity. Again we go to this level, as we are not getting any value here. We are going to this level alpha value 3 and beta value plus infinity. In this way, here we are getting these two values 0 and -2. And as max player is selecting the turn or the gain, then he will choose 0. If he selects 0, then alpha value will not change because current value of alpha is 3 and the new value which is coming is 0. As the current value is better than the new value, so max will not change his alpha. Now whenever here 0 is coming, in this level mean player is playing. So in this level beta value will change. In which level mean player is playing, in that level beta value will change. We know that. In which level alpha will be updated, where max player is playing. And where mean player is playing, in which level, in that level we can change the value of beta. If the new value is less than the current value of beta, then it will change. So here the beta value will change to 0 because one option is there of 0. So now we see that alpha value is 3 and beta value is 0. So again one pruning will occur. So this subtree will be pruned. So here we can understand that 0 or less any value will come. Either 0 or any lesser value, because mean will select the value. So if it is bigger than 0, the other value is bigger than 0, then 0 will be selected. And if that value is less than 0, then that value will be selected. So whatever be the value of this node, 0 or less value will come to this. Here we are getting 0 or less value. So max will not be updating this alpha value. Max will not update the alpha value. Now we come to this level. So when we go to that level, then alpha value is 3 and beta value is plus infinity. Alpha value is 3, beta value is plus infinity. Again we come to this alpha value 3 and beta value plus infinity. So among these two values, again we have to select any one value. As max is playing here, 8 will be selected. And as 8 is bigger than the current value of alpha, that's why alpha will be modified to 8. As 8 is selected here, again in the next level or in the previous level, mean can modify beta value. Beta is plus infinity here, and here mean player is getting the option of 8. So as 8 is less than plus infinity, beta will be updated to 8. So now alpha is 3 and beta is 8. So again we go here with alpha 3 and beta 8. As alpha is less than beta, that's why no pruning is done. Now again in this level 9 and 2, these are two values. As max will select the maximum gain, so he will select 9. So if 9 is selected and alpha value will also be modified to 9 because 9 is a better value than 3. So 9 will be the value of alpha and beta is 8. So 9 is greater than 8. That's why this subtree will be pruned. So this is one problem. I'll show another problem that I have given to the class. So now we consider the second problem. This is the game tree, and in the first level max will play and in the second level min will play. Max level is shown by rectangle and min level is shown by circles. So now we start with alpha equal to minus infinity and beta equal to plus infinity. In this way, if we come to the lower levels, we come here with minus infinity and plus infinity. And after coming here, we are getting 5 and 6. And in this level, min player is playing because it's circle, so min player is playing. If min player plays again, then he will select the lower value. So 5 will be selected and beta will be modified to 5. Beta will be modified to 5. After that, in this level, as max player is playing, alpha will also be changed and will be modified to 5 because the current value of alpha is minus infinity. Then minus infinity, 5 is a bigger value. So alpha is modified to 5. So with alpha 5 and beta plus infinity, we come here in this level. Here. Alpha 5 and beta plus infinity. And from these three, 4, at first 7 is coming. If 7 comes, then what will happen? If 7 comes, then beta value will be modified to 7, and then when next 4 is coming, then again beta value will be modified to 4 because beta always chooses the lower value. So 7 is better than plus infinity with respect to beta and 4 is better than 7 with respect to beta, means the mean player. So beta value is 4 now. And if beta value is 4 and alpha value is 5, alpha is bigger than beta, then the remaining subtree will be pruned. So here we will get 4 or less value. Whatever be the value of this node, between 5 and 4, 5 will be selected because here max player is playing. If this value becomes 5, then again in this level, mean player is playing and he will update the value of beta. So value of beta will be 5 because then plus infinity 5 is better. So we come to this level with alpha value minus infinity and beta value 5. We come here with alpha value minus infinity, beta value 5. Here we get the value 3. Only one value is there. As 3 is present, so mean player is playing here. Mean player will update the value of beta because it will always update the value of beta whenever a lower value comes. So here 3 will be selected. Here also 3 will be selected. And among these two values, 3 will come here because mean player is playing in this level. So among 5 and 3, mean player will select 3. If this is 3, then in this level max player is playing and max player will update the value of alpha to 3. If value of alpha is changed to 3, then we go here with alpha value 3 and beta value plus infinity. From that level, to this level, alpha value 3 and beta value plus infinity. From that level to this level, alpha value 3, beta value plus infinity. Here 6 is present, here mean is playing, so mean will update the value of beta. So value of beta will be 6. If 6 is the only value, this node will also be 6 and this node will also become 6. Whenever this node becomes 6, then here max player is playing because it's rectangle. So if max player plays, then this alpha value will be modified to 6 because 6 is better than 3. Then 6 comes here, and for this, in this level, mean will modify the value of beta. And beta will become 6 because 6 is better to mean player than plus infinity. So we go to this level with alpha value 3 and beta value 6. Okay, sorry, before going to this, here one subtree is present. So I will go with alpha value 6 and beta value plus infinity because here alpha value is 6 and beta value plus infinity. So alpha value 6, beta value plus infinity, and I am coming to this level. Here 6 and 9, two values are there. As mean player is playing, mean player will choose 6. And if 6 is selected, then beta will also be modified to 6. Here alpha equals to beta. We know that whenever alpha is greater than equal to beta, then pruning occurs. As here alpha is equal to beta, so here also one pruning will occur. So whatever be the value 6 or less, here the value 6 will come, and for this 6, this beta value will be changed to 6. So alpha is 3 and beta is 6. Again I am coming down with alpha is 3, beta is 6. Then the value 7 comes. If 7 is the value here mean player is playing. He has to select 7, but he will not modify the value of beta. Here also 7 will be selected because only one option is there. But whatever be the value, 6 will be finally selected here because mean is playing, and among 6 and 7, mean will prefer 6. So whenever 6 will go there, then in the upper level, the value of alpha will be modified because here max is playing. So if max is playing, max can modify the value of alpha whenever a bigger value comes. So as 6 is bigger than 3, so alpha value will become 6. So when we go to this level, alpha is 6 and beta is plus infinity. Alpha is 6 and beta is plus infinity. So we go to the lower levels with that value. So alpha is 6 and beta is plus infinity. I am going down. Alpha 6, beta plus infinity. After coming here, I am getting these two values, 5 and 6. So among these two values, I have to select any one. That is, mean player will select any value. So he will select 5 because 5 is a lesser value. So if 5 is selected, then this beta value will also be modified to 5 and alpha becomes bigger than beta. So here also one pruning will occur. So we get a value which is 5 or less. Here also we get a value which is 5 or less. Whenever 5 is here, then in this level max player is playing, but max player will not modify its alpha value because alpha is currently 6. 5 is not a better value than 6. That's why max player will not modify the value of alpha. But here 5 or any less value will come. If 5 or any less value comes in this level, mean will play. So mean will update the value of beta and it will become 5 because 5 is better than plus infinity to mean player. So beta is becoming 5 whereas alpha is 6. Alpha is greater than beta. So here also pruning will occur. So this subtree will be pruned. Now our next topic is constraint satisfaction problem. CSP. Constraint means some restrictions. Satisfaction problem. That means when we are solving those problems, we have to satisfy or we have to maintain those restrictions. This is called constraint satisfaction problem. In CSP, we are given two things. One is a set of variables. Another is a set of constraints. This is not constant. This is constraint. That is restriction. And what is constraint? Constraints are the restrictions that has been imposed between two or more variables. We are required to assign value to those variables from a specific domain so that all the constraints are satisfied. Now I will come to two problems which can be addressed as constraint satisfaction problem. One problem is n-queens problem. Another problem will be graph coloring problem. N-queens problem. In n-queens problem, we will be given a matrix of n cross n size. So first I am considering a 5 cross 5 matrix here. 5 rows and 5 columns are there. I have to place 5 queens here. But some restrictions are there for placing those queens. How to place the queens? I have to place n number of queens in n cross n checkboard in such a way that no one attacks each other. No two queens are attacking. Attacking means we cannot place two queens in the same row, in the same column or diagonally. So if I place one queen here, this whole column, this whole row and this whole diagonal, those are blocked. Now, first I have considered 5 queens problem. So suppose I am placing the queens in this way. I'm just removing these dots and then I will place the queens. Suppose I am placing the first queen here. I am giving the row number and the column numbers. Then the second queen I cannot place in the same column or same row. I have to select the next row and not in the same column also. I can place it here. Whenever I am placing it here, then this queen, first these dots are the blocking of this queen. Then when I place the second queen, then this queen blocks this column, this row and the diagonals. This diagonal is already blocked, these two diagonals. So for placing the third queen, I have two options, either in this or in this. So suppose I am placing here the third queen. Whenever I am placing the third queen here, this column is blocked, this row is blocked, this diagonal is blocked. Those are already blocked. So I have to place the fourth queen. When I place the fourth queen, I can take this because this is empty. So I place the fourth queen here. So this entire column, this entire row and these diagonals, this one, all the diagonals are blocked. And for placing the fifth queen, I have only one cell left. So I have placed that queen. If I do not place in this way, if I place the fifth queen here, then 1 will be the cost. Because here, no, not 1. Here the cost will be actually, here see one restriction is not maintained. So 1, and see here in the same column 2 queens are placed. So another restriction is also violated. So one is diagonal violation, one is column wise violation, that is 2 violations. And here with this queen is attacking in the diagonal portion. So 3. So cost function is actually the number of restriction violation. So here I am violating 3. Means 3 times the rule is violated. That's why the cost function will be 3. But if I place the queen here, then it's fine. This is one solution of 5 queens problem. There are many solutions because here see we had 2 options. One was here, another empty space was here. So I could have selected this place also. So that can lead to another solution. Or when I have placed the second queen here, then also I had this place and these places also. Those were also the options. So I could have been placed those the second queen on that places, on those places. So those also can lead to some other solutions, but this is one solution. So this is constraint satisfaction problem. Another is graph coloring problem that we already know. Maybe in graph theory, we know graph coloring problem. Suppose I have a graph and I have to color its vertices, but in such a way I have to color so that no 2 adjacent vertex will have the same color. So if I give red here, red will not be given to this node or this node, this vertex or this vertex. I have to use green, I have to use blue here, but in this node I can give red because this is not adjacent to that. But I cannot give green or blue because these 2 are adjacent or these 2 are adjacent. Here also I cannot give green because this is adjacent to this. So this is graph coloring problem. So if I write R here, then 2 will be the cost function because I am violating the constraint 2 times. Once here, another time here. So these are constraint satisfaction problem. And then comes according to your syllabus, I am talking, there is probabilistic reasoning. This probabilistic reasoning totally works on conditional probability. Suppose I consider this image, smoking and air pollution. Smoking also can lead to lungs cancer. Air pollution also can leads to lungs cancer. So if somebody has lungs cancer, then if we want to find whether it's due to smoking or due to air pollution, then we have to find the probability of lungs cancer if the person smokes, and probability of lungs cancer if the person is not a non-smoker. So lungs cancer may occur due to only air pollution. In those cases, we have to consider the probabilistic model, and we know that probability of A given B, this is conditional probability, is equal to probability of B given A into probability of A divided by probability of B. This type of conditional probability based problem we have already done. So the more part is actually included in Bayesian network, but that is excluded from your syllabus, so I am not going to the details. Some problems you may practice from this conditional probability model. 3 topics are remaining. One is mean end analysis. Mean end analysis is also about how to restrict a search. Means if I have a very large state space, I have to find many, I have to check many nodes. Then if I can get any reasoning, any logic to omit some of the nodes, then my search technique will become efficient. Means it will take less time, less space. So logically I have to omit some nodes. I cannot omit randomly because those nodes may have the goal node. So when I try to omit some nodes, I have to find some logic. Why will I will not search that part? If I can find that part or that logic, then I can skip some of the nodes. Just like alpha beta pruning that we have already done. So this is a just overview of mean end analysis. And still some points are remaining. One is agent, another is truth maintenance system or like that, and some is another is default reasoning that I will give you some notes. And if you have any problem related to Prolog programming, you are free to ask. You can post your questions or your codes to Google Classroom. So thank you. I think we have covered almost 95% of our syllabus. Thank you.